Hello guys, good afternoon. You are welcome to my YouTube channel, the Explicit Tutorials. As you all know, my name is Mr. Joseph. Please, as you are watching this video, endeavor to subscribe, like, share, and comment. Just as I promised us, I said that today I will do justice to circular motion in physics. So please, as you are watching, endeavor to subscribe so that when I upload subsequent videos, you'll be notified by YouTube. Now the topic is circular motion and what? Gravitation. What is the meaning of circular motion? Circular motion is a movement of an object in a circular manner with uniform speed. Please take note, with uniform speed or what? Velocity. The movement of an object in a circular manner with uniform speed or velocity is known as uniform circular motion. It is known as what? Uniform circular motion. That is it. Very, very easy. Take note, with uniform speed or what? Velocity. Then let me use an equation to illustrate what I just said. I have this, forgive my diagram. So I have this velocity, and of course this is a mass, right, that is being swung. This velocity, this velocity, velocity. So what does that tell you? Look at the body is moving. It's not going like this, okay? It's not going this way, it's like this. I don't want to put it round, okay? It's moving like this. So if that is the case, here is velocity, velocity, velocity. So what does that tell you? So it means towards the middle of the circle you have acceleration, 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 and you have what? Acceleration. Now, of course, the movement of this body in a circular manner is called what? Uniform circular motion with what? Uniform speed or velocity. However, the force, please take note that centripetal acceleration is given as what? V squared over what? R. Centripetal acceleration is given as what? V squared over R. However, the force that is needed to keep this body moving in a circular manner, the force that is needed to keep this body moving in a circular manner is called what? Centripetal force. And it's given as what? Mv squared over what? R. Of course, know that F is ma. Take note of that. So this is the formula of centripetal force, which is mv squared over r, and this first one is what? Centripetal acceleration. Don't take this for this. In centripetal force, the mass of the body is included, but in centripetal acceleration, the mass of the body is not what? Included. So please take note of that. It is very, very important. So we've established that already. So let's jump into, please take note that velocity is also equals angular this. Now, this sign here represents what? Angular velocity. So if I should make it the subject formula, it becomes arrow, arrow. So this will go into this. So it means that W is equals what? Velocity over what? Time over radius. So this sign here, W is the angle. Let me just write that angular velocity. This is the angular velocity. Arrow is the radius, and V is the linear velocity of the particle. The linear velocity of the particle. Don't take the angular velocity for the linear velocity. It can lead to death. You understand? It can lead to death. So just take note of the way the formula is written. So this is angular velocity. There's a formula. Please take note of that. It is very, very important. Which is what I usually say. Very, very important. Very, very important. So the next one is the movement of an object in a circular track. There is motion, I'll use the word motion in a circular track. Everything's about circular. So let me use a diagram to deduce the formula, okay? If I have this, or should I just give us the formula straight? If I have this, for example, there's the height, isn't it? I can make here my angle, then mg, right? Here is what? Your acceleration. And this region is arrow, which denote what? Normal reaction. Normal what? Reaction. And this point is called what? Center of gravity. And here is called what? The frictional force. While this one is what? The normal force or normal reaction. Not normal force, please. It's called normal what? Reaction. So from what we have here, I can deduce my formula easily. Just look at what I'm going to do. Becomes F times H is equals, take note that arrow is equals what? mg. Mass times what? Gravity. So F times H is equals arrow times A. So arrow times what? A. But I've given us that arrow is mg. Therefore means that FH is equals what? mga. True or false? True. In place of this arrow, put what? mg. Is understood. Therefore, A over H is equals mg over, is equals F over what? mg. Are we confused? Any confusion? No, I believe you. So this is what I did. F times H, you have FH, right? So A times mg, you have what? mga. So I'll make this equation what? 1. Is it clear enough? So the next one is, what do we have here? This should be tan theta. Tan theta, which is opposite over adjacent. Opposite here is what? This angle. Then the adjacent is what? H. You have what? H. I believe that is understood enough. It therefore means that tan theta now, tan theta is equals what? A over what? H. But F is equals what? mv squared over what? R. I gave you before that mv squared over what? R. That is from the initial formula that we got, that is centripetal what? Force. Now, since you've gotten to this point, all right, it means that tan theta now, tan theta is equals what? mv squared over r. Tan theta is equals what? mv squared over r. Look at the formula I'm trying to deduce. I'm deducing tan theta is equals what? V squared over what? R. This is what I'm trying to what? Deduce. All right, you'll get it very soon. But we know that mv squared over r is equals what? 1 over what? Mg. That's 1 over f. 1 over f. This 1 over f. This f here connotes what? Mg. It connotes mg. It connotes mg. So what does that tell you? If mv squared times 1 over mg, m is common, so cancel out m. It means that tan theta now, this times this is v squared over r times g is what? Rg. However, let me say something. Now that theta is equals v squared over r, skidding will not occur. Skidding will not occur. What is the meaning of skidding? The word skidding. Skidding is just like a phenomenon characterized by a body sliding from its normal position When the body slides from its normal position, we call that what? Skidding. And it does not occur if tan theta equals v squared over what? Rg. However, skidding occurs when tan theta is greater than v squared over rg. These are the kind of questions they'll bring. Which of the following can result to skidding? Which of the following can result to skidding? Alright, when the body is moving in a circular track. Alright, please, when tan theta is greater than this expression, you have what? Skidding. So v is velocity, r is radius, and g is what? Gravity. So that is what we've just done is that is body moving in a circular track. I believe it's understood enough. The next one is a body moving in a blank track. Or before I go into that, let me give us something. We all know that potential energy, we know that potential energy is the energy possessed by a static body, or it is the energy possessed by a body at rest, and it's giving us mgh. This h can also mean what? Length. So there's m times g times h gives you what? Potential energy. But the opposite is the kinetic energy. Kinetic energy, which is Ke, we all know what it means. It is the energy possessed by a body in motion. So it becomes 1 over 2 mv squared. However, in a simple harmonic motion, kinetic energy is given as half mw squared a squared minus what? S squared. This m here connotes what? Mass. This w is what? Angular velocity. This one is angular displacement, while this one is what? The current displacement of what? The particle. So please take note of these three formulas. They are very, very important. Alright, so the next one is motion in a blank track. Motion in a blank track. Motion in a blank track. I'll use a diagram to deduce my formula as usual. If I have this, something like this, I have my angle situated at this region. I have a normal reaction here, which is R2. I have another normal reaction, which is what? R1. Alright, between the space between this and this, there's what? Frictional force 2, and here is frictional force what? 1. But I can make this point to this point as A to what? Point what? B. Alright, so that is what it is. However, at this region of the diagram, you have what? Mv squared over what? Arrow. And I know that mv squared over arrow is what? The centripetal force that keeps the body moving. I believe it's understood enough. Shall we deduce a formula? Now, from what we have that R1, R2 becomes, we are going to resolve this along the x and y axis. R1 plus R2 sine theta is equals what? Mv squared over what? R. R1 plus R2 cos theta is equals what? Mg, which is F. The next thing we have to do is to divide equation 1 by what? Equation 2. We'll divide equation 1 by equation 2. In doing that, what are we going to be having? Something like this. So this we're going to do this. Sin theta divided by cos theta is tan theta. Yes, just resolve it yourself. Sin theta divided by cos theta is what? Tan theta. So it means from here I'll be having mv squared over what? Mg. Sorry. I'll be having mv squared rg. Is that okay? Times, that is mv squared over r times what? 1 over mg. Alright, so this guy will go into this guy. It therefore means that our tan theta now equals v squared over what? Rg. Is that not correct? V squared times 1, we have v squared. What kind of mistakes are these now? So r times g is what? Rg. This equation 1. However, if I should make v squared subject formula, it becomes v squared equals what? Rg tan what? Theta. If these two crosses, it becomes a square root here, so which means this idiot will go out. So I'll make this one equation what? 2. If I want to do the tan inverse of this, I'll be having theta equals tan inverse of what? V squared over what? Rg. So this equation what? 3. So what I've just done is motion in a blank track. You saw the way I deduced it. However, there's what called tangential velocity. Tangential velocity is given as what? Oh God. Which is v. Is given as 2 pi over what? Period. 2 pi over period. So please, as the class progresses, we are going to be using this formula to solve questions. Very, very important formula. So take note of that. So what I've just done is motion in a blank track. And the first one was motion in a circular track. So please follow it bit by bit. It is very, very important. So the next one is Kepler's law. What did Kepler say about gravity? What did he say about gravity? What were his laws about gravity? He said, 1, that the orbit of the planet is in ellipse with the sun at one of the two foci. 2, he also said that the line joining the planets to the sun draws out equal areas with equal time. That is law 2. Law 3, he also said that the square of the period of the resolution of the planets is directly proportional to the cube of the mean distance from the moon. So which means I can express as t squared r cube. Excuse me, hope it's recording. Yeah, it is. Yes, I have to check. Yes, it has happened to me severally. 1 hour talking, and at the end of it, I'll now realize that I'll be talking to myself. So please, that's why I usually check in. So these are the three laws as stated by Kepler. They'll ask which of the following is false about Kepler's law of gravity. So take note of these three laws. This first one caught my attention. It said that the square of the period of the resolution of the planet is what? Directly proportional to the cube. Cube means 3 of the mean distance. The distance here is what? Radius from the moon. So which means t squared, which is the period, arrow cube. Now this is a law stated, or these are the laws stated by Kepler, alright? So the next step is we are going to be using diagrams to deduce this. How did they arrive at this point? So let's try it. Let's try it. Let us give it a try. So I have this, and I have this. Okay, from here to here, I'll call it, there's a sun, mRw squared. Here it is the mass, and here is what? The planet. Alright, so from this region is the sun. Or let me, okay, you have the sun here, there's the mass, and this place becomes the moon, this moon, planets, then mRw squared. So what I just illustrated was done according to Kepler. H1, H2. H1 waiting, H2. Let's deduce our formula. Now, the force acting on the mass of the planet, the force acting on the mass of the planet is expressed as, you have that F equals mRw squared. The force acting on this mass is what? Written as F equals Km over what? R squared. Now, what does this information connote? It connotes that the force is what? Directly proportional to the mass and inversely to the what? Radius. I'll take it again. The force acting on the mass is what? Directly proportional to the mass and inversely to the radius, which is the distance that separates them apart. From what we've gotten already, I gave you from a period that's, oh, I have not given us, let me do that now. Period, what is the meaning of period? Period means the time taken for a body to make one complete oscillation, or it is the time required or needed by a body or a wave particle to make one complete oscillation, and it is given as what? 2 pi over what? W. However, this W is a symbol, not the normal W you and I know. Alright, it stands for what? Angular velocity. Angular velocity. And of course, that period is noted using capital T. Period is noted as what? Capital letter T. From what I have here, we have to make angular velocity subject formula. In doing that, I'll simply cross multiply. This times this is what? Wt equals what? 2 pi. So what do? Divide both sides by t. This will go into this. Is that not correct? So it means that this is equals to this. So Km over r squared is equals mr. Don't forget, I'll substitute this into what I have here. Becomes 2 pi over t all squared. Okay, it's clear, you know, very, very simple. So it becomes Km over r squared equals mr. This 2 times 2 is 4. 2 times pi is pi squared. Then 2 times t squared is over what? T squared. I believe it's clear enough. So mass is common here, mass is common here. So they have to get out when they're clear for us. So what do you do next? You what? Cross multiply. In doing that, you say k times t squared. You have what? T squared k equals this times this. Is something missing here? Okay, something is miss. Okay, it's not missing. All right, so this we're going to this, then this times this is what? This. So this times this, I'll have 4 pi squared r cube. Yes, r cube. You're now asking me, how did you get that r cube? I got the r cube from this. R squared times r here is what? R cube. All right, so you divide both sides by k. Alright, so this, we're going to this. Therefore, t squared now is equals what? 4 pi squared r cube over what? K. So this is what? Kepler's third law. He said that the period of the resolution of the planet has a direct relationship to the cube of the distance from the moon. And of course, if this has a direct relationship with r squared, it means that 4 pi squared over k is what? Constant. So what I've just done is for this first guy. Hope it's clear enough. It's for this first one. So with this, we are almost done with this with this part of the video. Though before I round off, I'll solve some questions to actually call it a day. Very, very important. So which means we've been able to deduce what Kepler said in the third law. So t squared is equals 4 pi squared r cube over what? Over what? K. So that is what you have it to be. Now, I'll not rub off these parts. From the second law, F is equals what? mRw squared. If I should do same thing I did here, I'll arrive at this point. Okay. I will let me take it back a bit. Let me bring it here. Let me bring everything here. I want to bring it this way, okay? So if I'm bringing it here, it therefore means that 4 pi squared. In the first F, we used small letter r as the radius. So this other r here, we have to come down, which will represent what? The radius of the moon. So over what? C. And this guy has inverse relationship with 1 over what? R squared. The same thing we did here. The same thing we did at this point. Okay? So which means we used small letter r squared, but now it's not big what? Big letter r squared. So what do we do next? We leave it, don't touch it. It means that F is also equals to 1 over what? R squared. 1 over r squared. Remember, this k here is constant. So if F is this, please, let me use inverse sign. If F has inverse relationship with r squared, it means whenever I see F, I'll put what? Mg. Is that not correct? So Mg now is inverse proportional to what? 1 over what? R squared. Let me call this equation 2 and this equation what? 1. So let's continue from there. I'll rub off. Why is my nose itching me now? Where's none of this? Now, from here, we'll divide equation 1 by equation 2. Alright? So in doing that, we'll be having 4 pi squared mr over r squared mg. We're having r squared mg. Let me check if I can. Please, I think is it c or t squared? From this point. Oh, it's t squared now. Alright, so from here, or let me just bring like this. Say times 1 over mg, alright, because this one now becomes mg equals, now k over whatever. So if I want to eliminate this sign, so, and it's equals to this one and this other one. So if I have 1 over r squared divided by 1 over r squared, what does that tell you? If I want to re-express this idiot, it becomes 1 over r squared. This a division sign becomes divided by 1 over what? R squared. If I should introduce times into this expression, what will I be having? I'll be having 1 over r squared times r squared over what? R. Is that not correct? So from here I'll be having r times 1 is what? R squared over times 1, sorry. Then 1 times this is what? R squared. So from here I now have that 4 pi squared mr over r squared mg is equals r squared over what? R squared. R squared over what? R squared. So what do we do next? These idiots can now go out. So from here, I want to make g the subject formula. This will multiply everything here, becomes r cube g, right? Is that not correct? If that is r squared times r squared, is it r squared now or what? Is it r squared I'm supposed to write here or just r? Let me check it too. Where is this mistake coming out from? 4 pi. What am I using k squared now? 4 pi, please. 4 pi squared. Where is that r coming out from? No. It's r. I cannot find it now. Where is the initial r? It cannot be this, okay. So please, you now have that r cube is equals, I think we've passed the place. I don't want to go back. If I should go back, it will affect us greatly. Okay? So please, then you now have r times r squared is what? R cube, you have g, then equals, I think 1 arrow, we have to cancel out 1 arrow here. I'll now be left with just 1 arrow. So which means that 4 pi squared arrow. 4 pi squared arrow. So divide both sides by arrow cube. Wait, I was wondering where will I be having that stuff from? So it's what? T squared. It's not even, you have to be t squared. So what do we have next? This times this is, okay, that is t squared r squared g. All these squares are confusing somebody. So this 4 pi squared times r. So divide both sides by t squared r squared, t squared r squared. So this will go into this, and now that g is equals 4 pi squared r over t squared r squared. So that is what you have the formula to be. So this one is from the second f, and the first one is this first one we got. Where is it? Is from the second f. All right. So are we done? Okay, so what we've just deduced is what? Kepler's law. Kepler's law of what? Gravity. So the next one is Newton's law of gravity. Newton's law of gravity. What did Newton say about That is Newton's law of universal gravity. That is a complete word. Newton's law of universal gravity. What does the law state? The law states that the force of attraction or repulsion between two masses, m1, m2, it said that the force of attraction between two masses, m1, m2, all right, is directly proportional to their product. You know m1 times m2 is product. The force of attraction between two masses, m1 and m2, is what? Directly proportional to the product of the masses and inversely to the square of the distance that separates them apart. Then Newton used a constant gm1 m what? 2 over what? R squared. Over R squared. So what do I do next? I want to make G the subject of the formula. In doing that, I'll be having F R squared equals gm1 m2 over R is okay. I'll be having gm1 m2. So what do I do next? I'll divide both sides by m1 m2 m1 m2. So this will go into this. Means that G is equals Fr squared over m1 m2. So this is what you have it to be. This G has a constant. Is given as 6.67 times 10 raised to power minus 11 Newton meter squared per kilogram squared. So this is the constant. Why do you think is Newton meter squared per kilogram squared? Let me show you why it's like that. The SI unit of force is what? Newton, right? Is that not correct? Newton. Then radius here represent what? Distance, which is what? R squared. So meter, R squared. That one is established. Then you have two masses here. M1 times, you can also M times M. That will give you what? M squared. And you know that the SI unit of mass is what? Kilogram. So if this guy, I have Newton meter squared over M squared, or let me just use the kilogram squared here. If this kilogram squared should go up, becomes nm squared per kilogram. It becomes what? Minus. So for me to cancel out this minus, I'll just put a slash here, then I'll have my value. So this is what you have it to be. In terms of dimension, this will definitely, it will become a different thing entirely, but I don't want to go there. Mass is mlt minus 2 times r squared over m squared. I'm left with what? 1m, right? So I have L here, let me use L as length. That is, how to equalize it, this one becomes L cubed, right? L1 times this, I'll have it to be what? L cubed. Therefore becomes m minus 1 L cubed T minus what? 2. So this is a dimension of what? Newton's universal constant. So that's by the way. So please, sometimes if you don't remember the unit of some entities, if you know their formula, you can actually deduce it. Okay? So we are done with this part of the video. So if you know you have not subscribed, do so that when I upload the next video on it, you will be notified by YouTube. So let's solve one or two questions. I will just dictate it because we've spent much time already. So I'll dictate, you will just simply write. Alright, I'll solve question 1, you solve question 2. Hope you are with a pen. Let's write. A car is traveling around a circular track. A car is traveling around a circular track with a radius of 10 meters. With a radius of 10 meters at